I'm going to welcome to the screen Will Wells. He's very busy with a whole bunch of things in his company just now. We're fortunate he's taking a short time off to tell us about what his company is doing and where things might go for better agriculture, and indeed why agriculture is important. I mean, typically sometimes say we had an agricultural revolution thousands of years ago, then we had an industrial revolution, now we're living through an information revolution. And that's true in one extent, but it ignores the fact that every time there's been a revolution in any kind of industry or information, it has led to another agricultural revolution. So let's hear from Will Wells.
Hi there. So my name's Will. I founded a company called Hummingbird just over a year ago, and we're an artificial intelligence company for farming. I have a team based in London. Half of them are academics, the rest are data scientists, software engineers, machine learning experts, and we predominantly use drones, and we fly it over farmland, and we help farmers see problems that they can't see with the human eye. So just to frame why we're doing what we do, so farming is in dire straits from a macroeconomic perspective. Agriculture covers 40% of the Earth's land mass, and population is growing at such a large rate that there should be 9 billion people by 2050. Just to put that in perspective, yields need to double every decade or so just for us to be able to feed everyone. So connectivity and technology has a huge role to play in farming, just for us to get the basics right. Thought I'd show a few photos of people in my company in action. Top left is at harvest last year in Wiltshire. The top right is in northern France. This is on a rainy day up in Lincolnshire. And the left-hand one is in a field in Spain. Hummingbird's a sort of young company, but we've already got some good inroads into some big European farms, and it's very exciting. So how does it work? So we turn up to a farm and we fly a fixed-wing drone over fields. We collect about 30 million data points per field on average. We can cover about 500 hectares a day, and once we've finished flying, that data is uploaded to a cloud where it's stored, processed and analysed. Now the data is uploaded in imagery form. It's not data as you and I know it, and what that means is that we have to create a patchwork quilt of images called an orthomosaic. That data is then combined with weather data, soil data, historic yield data, and we try and help farmers see problems that they can't see with their own eyes. So a yellow spot on a leaf on May the 5th in one geography will mean one thing, but it may mean something completely different to a farmer in Brazil looking at soybeans. How we get that data into the cloud and how we use networks, and particularly in rural locations where there isn't much Wi-Fi, and most of our customers have farm office with very low internet speed connections, is a huge challenge to us. So what do we just to talk about a little bit about the stuff that we're doing. So we're kind of looking for four main things. So the first is big low-hanging fruit. So can we see the flooding or drainage maps that the farmer can't see from the air? We're also looking at disease that the farmer can't see, and the reason for that is we want to lower chemical usage on farms. The big picture is that if farmers are able to get data on disease and nutrients fast, then they wouldn't spend and they wouldn't waste critically so much money on pesticides and fertilizers, which make up about 40% of all farming input costs at the moment. So it's a huge quantity. We're also able to predict yield, and the way we do that is we measure things like biomass, height. We know when the crop was planted, and we know what the historic yield was because we connect to that data source as well. So we fly at critical decision-making junctions in the season, and we're always looking out for different things every time we fly. So this data goes into a cloud, but is then immediately available on a smartphone. We try and always do a 24-hour turnaround, but sometimes the size of the data we upload and that needs to then be downloading can restrict this. So we have to create layers of Python code to compress the data. We have to use every trick in the book, whether it be 4G in the field or its super fast internet connection. We've even resorted to farmers sending their data by USB sticks to us. I mean, that's the reality of connectivity even in the 21st century. So this slide is less obvious, but it introduces us to probably the greatest opportunity presented by 5G connection and wider connectivity, which is real-time data from the ground, and then that combined with other forms of data and what that can tell you. So what you're seeing there is where a farmer has gone into his field and he's recorded everything from nutrients at a leaf level to soil temperature to taking a photo of a plant that he thinks has a problem. All of this gets uploaded straight away with a smartphone, and when you combine that with imagery that a drone is able to capture, plus satellite imagery, historic data, you're able to get a very compelling picture as to what's happening, even at a 2 centimeter per pixel resolution. The reason that ground-based sensors and that 4G and hopefully 5G will be able to solve is that it will allow us to ground truth in real time. Now what you're seeing here is an NDVI image of a field, and the bits in red are showing us where the crop is under stress. Now when we fly over with our drone, our algorithms don't necessarily know that that's disease. It could be slug damage, it could be flooding. And unless we have some connected mechanism where we have some machine learning capability on the ground to validate what we're seeing and connect it back up, the algorithms will never improve. So what 5G and what wider connectivity really introduce us to is they're able to unlock potentially the full machine learning potential of some of this technology, where all the devices can begin to talk to each other and understand each other better. This is some of the R&D we're doing, which sort of goes into detail more on that. But I think this is another example. So this is actually a weed map. Now, a weed will look exactly like a crop. So we have to generate an algorithm to differentiate between. It's almost like looking at DNA analysis. But again, unless we have a mechanism whereby we connect to the tractor and the tractor connects to the irrigation system and the irrigation connects to the satellites, many things can get lost in translation, and a farmer may apply herbicide to an area of crop that's perfectly healthy, which would kill everything. Our final product is our yield prediction tool, and this is a combination of weather data, crop height, biomass data, soil data, and how we combine all these data streams is vitally important. So I mentioned the tractor earlier. The holy grail for our industry is to be able to fly a drone live when a farmer is in his tractor. Unfortunately, at the moment, the hardware doesn't really have good enough connectivity to provide that data stream. But so for example, it would open up to us like all forms of augmented reality, whereby a farmer could quite literally peer into their crops and see an area of stress that we've identified. We've also been investigating ways to launch our drones from the tractors themselves. And because they're in close proximity, this would be the perfect live data feed. But as of yet, we haven't found anything reliable enough for us to use. So when we fly a field, we actually have two products. The first product is kind of what you see on your smartphone, the data stream itself. But really what this is just a shapefile, and this shows you a nitrogen treatment map where basically it goes over healthy areas of the field and doesn't spray any chemicals, and goes over unhealthy areas of the field and does spray more chemicals. And what you're seeing here is each grid has its own GPS coordinate. Now that has to be fed to the actual farm equipment itself, so that as it goes over the field, it knows where it is. Otherwise, you'd be spraying more chemicals on areas that don't need it. So this hopefully gives you a neat illustration as to some of the sort of return on investment potential for farmers. So this is another area this is another map that we produce. And just to put it into perspective, most of our customers are about 1,000 hectares or more. So just by applying chemicals a little bit more, in a more optimal format, can save some of them $100,000, £100,000. The cost saving is huge just by connecting some of the existing data forms already out there. And I think the reason why people get excited about agriculture is it's so big. And there are so many farmers that are using data sources, but to be honest, very little work has gone into connecting up the John Deere tractor with the irrigation system. The Met Office are useless. The great thing about drones is that you actually have a proprietary data collection tool that doesn't need anything else, and we don't even need to know what the soil type is. We can tell by how stressed a plant is as to how well it's doing. All we need is regulatory permission and we're up and away. So we're doing all sorts of R&D. We're trying to find ways to detect aphids and worms, and I think I'm the only person out of my friend group that spends 5 hours on a conference call talking about slugs. And as nerdy as some of this seems, there are some massive big picture food security, global agriculture, environmental protection, sort of big themes that are driving this space. And connectivity and 5G really provide the sort of big key to unlock at least some of the synergies that we'll be able to see by connecting all of these data sources. I'm going to make my presentation ultra short in the hope that we have lots of questions at the end, but there we go.
Well, that was fantastic, Will. Thank you so much. I mean, we'll have more questions in the end, but are you hiring, for example? Are you looking for more people to join that team? They seem to be doing incredibly interesting work.
So we only have 28 people so far, which is quite a lot for a company in just over a year old. We're very lucky. So Google and Dyson have invested in us, and some of the big agri companies. But one of the problems we find is that because the machine learning side of what we're doing is so niche, and because farming itself is an open system. So, for example, some of my data scientists say that analyzing MRI scans from cancer patients is easy compared to looking at septoria on wheat plants, because in farming you're open to all the elements, and the weather is always going to govern what happens more than any other variable. So you have to try and find the needle in the haystack and figure out what's happening on an underlying basis. But to answer your question, we're hiring in about 9 positions. So software engineers, we're looking for a meteorologist at the moment. We're hiring in digital marketing and sales, and we're always hiring basically.
And are there other companies overseas doing roughly the same thing that you're doing, or is it?
There's a couple. I mean, you get a lot of drone companies claiming that they're trying to solve agriculture, but when you lift the lid on them, most of it is crap. There are 3 or 4 companies we really respect that are using satellites and/or drone or plane imagery, but really we wish there were more. So there are 5 million farmers in Europe, and I'd say that maybe 10,000 are using drones. So the penetration is almost minimal, and as a result, we make a lot of very expensive mistakes that perhaps we wouldn't do if there were more of us. But
one final question for now before we invite Julian up, and then after he speaks, we'll have a panel discussion. You seem to be slightly critical of the Met Office. Did I pick that up?
No, the Met Office is fine, but all of these age-old institutions. So So we're a young company, which means that we create software that is very easy for a partner to access. Because we understand connectivity, which means our API is very open. So when you go to the Met Office, just by pulling local Met station data, it's clunky. They have no real they have like very slow and expensive internal mechanisms to allow people to connect to it, and they don't really get the more people that are using it all creates innovation and so forth. But they're okay. The Met, the other people are like you wouldn't believe companies like John Deere that are worth kind of $20 billion. They don't get it, but.
Sometimes the large companies have got large because they're doing some things incredibly well and they don't want to change their processes.
I think that's true, but the opportunities for some of the large companies by connecting to the sharp end of this stuff is huge.
Okay, we'll continue this discussion, but let's feed in some more ideas as to the future directions for agriculture. If I can invite Julian here. Julian will introduce himself as he talks, but I think it's fair to say you're part of a company that's even smaller than 28 people.
Oh yes, there's only 3 of us at the moment.
And you are looking at another way in which technology could transform agriculture. We heard earlier about robots doing building. What about robots doing farming?
I'm Julian Snape. My company is TVA GNC, which stands for Technovation Anglia Games and Consultancy. Oddly enough, it harks back a little bit to what we were talking about in the educational side of things. We use games in companies to help improve creativity and problem solving and so forth. But today I'm talking about the consultancy side, which actually is a high technology consultancy. We like to get our hands dirty occasionally, and we look around the world for interesting new projects, high technology projects, and we came across this called Farmbot. This is actually the machine on there is Farmbot Genesis, and it's touted as humanity's first open source farming machine. So I'll just go on one. It's been developed by a company called Farmbot Inc. in California by a guy called Rory Aronson, who's the project founder and CEO, San Luis Obispo in California, halfway between Los Angeles and San Francisco. The mission is to bring agricultural and automation to the small and medium scale. So we're sort of going the opposite end of the scale to Will, and coming down to the earth with a bump, quite literally here. It was originally funded by a Kickstarter in 2014, and by February of 2017, with Kickstarter and other sources of funding, they'd raised about $1 million for the first run. And they started shipping in late March, early April. It's all open source and it's all developed by individuals and companies worldwide, centered on Rory's company in California. Now I say shipping, they didn't actually ship as it comes like that, they shipped in kits. So when they arrive you have to assemble it yourself. Now if anyone is aware of or knows of the early days of small-scale 3D printing, particularly in this country with the RepRap project, Dr. Adrian Bauer at Bath University, it's very similar to that. In the fact you get all the kits of the parts and you can build it up into a Farmbot. Now, if I just move forward one more, what they wanted to do with Farmbot is to have the ability to plant polycrops in a machine-efficient manner. That's rather than farmers having all one field down to one particular crop, down to lettuces or carrots or cabbages or kale or whatever. This machine can actually plant lots of crops, or the same type of crop in the same area. It's also got the ability to optimize operations such as watering, spraying and seed spacing. The idea is to have it fully operational so it can run 24/7. Virtually unlimited farm design possibilities with it. It's a kit which can be expanded. It also incorporates, which is probably why it's connected with 5G and networking, it uses big data acquisition and analysis to actually drive decisions into making its farming even smarter than when it started out. Again, another capability is the ability to plant in the most efficient space layouts, to cram as much as you can in for productivity. It's scalable from a backyard system, from a small system, the initial development system that we're now working on, to an industrial operation. It can actually be built using the same software and the same techniques to almost any size. There's a bit of a moral aspect for it, for Rory's company, in the fact that they feel that they are allowing the democratization and decentralization of food production, hopefully reducing the CO2 footprints and actually allowing people to get more to grips with growing their own food, knowing where it's coming from on their doorstep. The main thing behind it, though, it is completely free and open source. You can go onto the website, you can go onto the documented bill of materials, and you can source the parts from wherever you like and put it together. It's tricky to do that, but it can be done, and we have done it once before. It's also fully hackable and fully accessible. Now, this is what it looks like. You can see on there, it's a raised bed. You don't have to have a raised bed, but just about everyone who's built one of these has a raised bed. It's about, it is exactly 3 metres by 1.5 metres. It's a gantry system, very similar to the early 3D printers. And you can see the little blue things on there are the motors. The little white thing on the vertical gantry is the electronic setup, and the thing down by the side is the power source. It looks very crude at the moment, and that's because it is quite crude at the moment, because this is a very, very new project and it's under open source development. And as more people buy the kits, more people source the parts and put them together, we all share our knowledge on it, and it improves day by day, week by week, and month by month. The next one there is just showing the very basics of how it works. There's a track, a main track either side that's attached to the top of the wooden bed in the X direction. And on top of that sits the gantry, and the gantry moves backwards and forwards, driven by the electronic system to cover the whole of the 3 metres. It can move quite fast, but with a 24/7 operation you don't really need it speeding around. You can actually move it fairly slowly and fairly consistently. And on the gantry is the business end, which is a vertical system, which at the end of which is a tool head. And that tool head is really what Farmbot is all about. I've just come to it's all about being effectively an XYZ CNC farming machine. Again, the original machine is 3 metres by 1.5 metres. The electronic side of it, again, to be as open source as possible, it's developed on a Raspberry Pi, which everyone can get access to, about 25 to 30 quid. Driving the actual machinery itself from that is an Arduino Mega board, on top of which sits a ramps output board, which drives 4 or 5, at the moment it's 4, but it can be up to 5, NEMA 17 stepper motors. It's commanded and driven via Wi-Fi with a web app. The actual hardware side of it, there are aluminium extrusions which come with the kit, or you can source that from any aluminium extrusion system company. All of the other parts are either available in kit form in aluminium, or they're available for 3D printing. CAD files, 3D printing CAD files available for download for printing, with laser, waterjet and stamp plates as well, which most of those come in the kit, but you can do those yourself if you've got access to CNC machines. Again, it's 100% open source. Anyone can do this. The software and firmware all driven via the web, which is why it's important to have connectivity and communications. The greater the bandwidth, the better. Not only for setting it up, but for what we come on to later is the future development of this whole project. All of the software is available on GitHub, as we had mentioned earlier again, in the education side of things. And it can be downloaded and installed anywhere and updated under the open source license. Anyone else making developments for it can upload their developments to it as well. All of the hardware is available on 3D CAD models with 2D drawings, schematics, and a full bill of materials with full web-based assembly instructions. And that's actually one area that we actually think needs improving, and we actually probably need a PDF downloaded system, because actually assembling one of these outside using a tablet, particularly in bright sunlight, is quite tricky, as we found out. The whole idea is all of this is open source, so anyone building and contributing to these contributes their knowledge and experience, and the whole of the source grows larger. And there's now even an open farm public domain database which plant growing regimes and people put in their information about what type of plants they want to grow, what the best regimes for growing those plants are, which are then shared by everyone else across the whole world. And this is what the very first prototype looked like. It's changed considerably since then. Again, you can see the X, Y, and Z with the actual business end on the X-axis. On the Z-axis downwards there. And this is what really the business end is all about. What it carries. It carries a number of different tools. Those are picked up by the actual UTM, Universal Tool Mount, which is on the end of the Z-axis. And that's got a magnetic system with it, and all of the actual tool heads have little magnets on it. The software positions it precisely above the top of these. At the moment there's just 6 tools, but again it's completely hackable, and we're already working on developing more tools to go onto the Farmbot. But the tool holders go at the end on the short end, at the end of both of the long ends. There's no reason why you can't place those anywhere on the system itself, but this seems the most convenient. If we go through them one at a time. First of all is a seeder, and the seeder head there simply has a little hypodermic type, it's almost like a cannula system attached to it. And on the actual UTM there's a pipe which has a suction tube, which is driven by a motor which is attached to the side of the actual bed itself. So when it's asked to pick up a seed, the seeder will activate. The UTM will come on, pick up the seed head, drive it over to where the seeds are kept, which are in a little seed pot, and can either be a pot full of all the same seeds, or there's a multiple seed pot with different seeds in the pot. It'll select the type of seed that the software is told to select by suction. It'll then go to where it's been told to go in the on the actual bed, on the actual earth part in the actual bed itself, and plant it. Again, working out how that particular seed from its database, how large it will grow, and how it will interfere with the other crops planted around it. Once that's been done, it starts to grow, and there are various other heads that will help it grow. First of all is the watering head. Again, the middle one there, which actually has another connection, again magnetic connection, which connects to a water pipe, and there's a water pump on the system. So it will know either from a regime that's set up, or it'll actually know automatically from various sensors that are part of the system going forward into the future. It'll know where the plant is exactly to the millimetre and exactly when it needs watering. So it'll then on its own go and keep that plant watered to the correct amount. If, as everywhere, the nasty little plant's out of place, the weeds start growing up, then it'll go and select the weeder. And again, it's got a system that'll be able to tell it where these weeds are growing. Once it's identified if a plant is definitely a weed, it's not in the place where the plant it knows should be growing is growing, it will go and pick up the weeder. It'll go and position itself above what it's identified as the weed, and it'll go and dip it right down into the soil, effectively killing it. To help it do its watering, you can even use pesticides and so forth with it as well, although lots of people buying this are buying it because they want organic, but there is a pesticide version available as well. But the soil sensor will go, and every now and again it'll go and check the soil for moisture, for acidity, and for whether it needs to put any fertiliser down on it. And all of this is driven by a camera sensor, which is again attached to the UTM, which can go and check exactly what's going on, make sure that the plants are where the plant should be, and this again can identify different types of weeds, and again it will learn different types of weeds that are common in different areas of the world where Farmbot might be working. Here's the electronic setup. That's one of my co-directors just setting up some of the wiring. Again, as I said, it's Raspberry Pi on the left-hand side is the actual brains behind it. It's an Arduino Mega. It's underneath the red circuit box at the end there. Which is the ramps box, which allows you to draw out the power to the motors and also power to encoders. And encoders are tricky little blighters at the moment, because what they're supposed to do is to keep an accurate picture in all axes of exactly where Farmbot is, but there's been a little bit of a problem with those at the moment, which we're fixing. But they should be able to tell Farmbot exactly where it is to the millimetre at any particular stage in its operation, but also if it suddenly stops running for any reason, say a bird has hit it or a branch has landed on it, it will stop and it won't burn out the motors or it won't completely hang the system. It will then alert you by an app that you've got a problem with it, and you can go and have a look at it and sort it out. Again, Polystepper drivers, again open source, available for a few pounds. Never 17 stepper motors actually drive the system itself. And this is where we come to the connectivity and networking aspect of it. The actual software is driven from the cloud via a web app, and as you can see there, it's been designed to make it as much like a computer game as possible. So you've actually got little icons for all different types of vegetables that relate to the actual data for those vegetables and fruits in there, or any other type of plants, herbs and so forth on it. It runs both on a PC, on a tablet, or even on a smartphone. We've had ours running on a smartphone quite successfully. And again, you can plant your garden just by using the graphics of these vegetables. And that's how you lay out the actual bed itself. You can decide, you can zone areas for different types of plants. You can just interspace them all completely, because it will just treat each individual plant as an individual entity as far as its regime is concerned. But most people tend to think that they're putting them all together at once, so it sort of keeps a little bit of the energy of the system down, because it can treat a small area at once with one particular regime before moving on to another regime, so it doesn't keep on having to constantly track back to pick up a new working head. Then there's regimes. Now these regimes are at the moment manual, where you know for each type of plant when it should be watered, what to look out for it, when it should be, if it needs any fertiliser, if it needs any particular looking out for slugs or insects on it. Also if it needs any particular checks for any particular blights or disease, to take the camera over at different times. And you can set up multiple of those. There's virtually no limit on the number of regimes you can set up, and again, all driven from the cloud. But the most interesting thing is what is now being developed from it. All that information is being uploaded into a decision support system for it. And there are multiple ways of doing this, and they will all be brought together to make the whole Farmbot system more effective. Manual input, as I've said before, you can enter the details of your own regimes into it, or pick those regimes out from a companion plant database, which is available of it. Soil data can be analysed and checked using the soil sensor sample sensors. Plant data that you've input into it itself can be taken or actually analysed from the camera. Again, going back to the Met Office, there's a system where it takes weather data. Now that can either be externally sourced weather data, or even if you have your own little local weather station attached to it, that weather data can be uploaded to the system. All of this is taken on a time and location basis, so it knows what your latitude is and what time it is, which hemisphere you're in, and we'll be able to measure and make decisions based upon that, based upon the type of plants you've planted. It can also, as the system grows and develops over the next few years, be able to take past successes and potential failures and feed those into the decision support system, which again flows through to the operating settings and then controls the Farmbot itself. Farmbot versus the grocery store. Now this little exercise they did for Farmbot Inc. For the US market, of course. Yield has been estimated that one Farmbot can grow enough vegetables for one person for 1 year, but that does assume a 24/7 all year round growing environment, which we probably don't quite have in this country. Sustainability, there's a lower 25% lower CO2 footprint, which gets even better if you start to use solar power for it. And the cost, it reckons that over about a 3 to 5 year period it would actually pay for itself. That will come down significantly, because these devices are not cheap, but they're not dramatically expensive. But we're working on ways of getting them a lot cheaper. They're also very, very ready for expansion. That's where my company comes into it. As I mentioned earlier, you can have a weather station attached to it, you can develop your own, or you can hook it into your local weather forecasts if there's decent weather hookups for it. You can go off-grid. We're already working with a local solar power company to be able to power it via solar to again reduce the CO2. emissions, and also make it so you can move it out of areas being close to a Wi-Fi network at home, so you can then use it with 4G or 5G away from it, say an allotment or somewhere like that. And also we're looking at using grow lights with it, so you can use it indoors as well. Interesting note that some people have said, oh, this sort of system, you can use it remotely, you can use it continuously off-grid without having anyone there, you can use it indoors with grow lights, and some people said, oh, you're going to get a lot of interest from your cannabis growers. So, but not quite sure whether that will be the case, because they probably need quite a lot of these to be able to grow the quantity that they grow at the moment. Again, it's all helped out via a open source forum. And you can see I'm second one down there, where we're having a problem with our encoders. Anyone has any problems with it, getting it to run, normally you get an overnight fix from it. You jumped on by a lot of experts in the field with it. And we're also talking to different developers of Farmbot. We've got different ideas of how we want to develop it and take it in different directions, all done via the forum. Again, Farmbot are openly idealistic about this, and they say that we believe that the business is a powerful agent for change, and like our products, can be more powerful when its details are openly shared for inspection, modification and replication by others. The following aspects of our business will be shared for the benefit of our company, our customers, aspiring entrepreneurs and the Farmbot community at large. Detailed sales and financial information, including but not limited to revenues, expenditures, profits, salaries, investments and taxes, cultural, operational and statistic insights that will determine importance to our growth and success. We'll default to transparency in all aspects of our business except where there are individual or partnership privacy concerns. Effectively, not only is it open source, it's also open book, which is quite scary for a lot of people in the business community. Our company, we are Farmbot Genesis providers and installers. We can provide full kits, we can provide semi-installed versions or fully installed versions, but more excitingly we are attempting to develop larger scale versions for use in under glass for agriculture in some of the local growers. We're also developing small scale versions for use in schools and colleges and in confined spaces, even on a windowsill. We're developing a stackable version, which is 1 metre squares that will go on top of each other, that can be used indoors in the corner of a room with grow lights. Again, that will probably be using an artificial arm on it rather than a gantry. Other ideas are being developed and added to all the time, and we're happy to work with individuals and companies in the spirit of open source.
Thank you so much, Julian. That's great. Let's have both of you maybe you can share this mic. Julian, what would you say to the observation? This looks like a very interesting hobby. It's something that might be able to give food for one person for their own use, but it's not practical to scale up to make a big impact on the needs of the agricultural industry as a whole. And these are small units and they're not going to occupy large fields.
Yeah, I'd say exactly right. It's designed for the smaller scale, it's designed for the independent home user who wants to grow their own vegetables and their own fruit, but perhaps doesn't have the time or doesn't have the capability to do it. But it is scale up to a certain size, and we're particularly looking at the under glass market in the greenhouse market, because lots of commercial greenhouse growers already have racks and trail systems, track systems in the greenhouses which can be utilised. It will need a little bit of a redesign for it, but we think it can be used for small scale agriculture. If you're going anything larger than that, then yes, you'd be wanting to use your autonomous tractors and systems, hopefully led by Will's agricultural assessment systems as well, drone-based assessment systems.
And I was going to ask about there is a movement in agriculture called vertical farming, in which more and more things are done indoors rather than in the old methods, and there's meant to be much more cost effective in terms of less greenhouse gas emissions and so on.
Yes, that's what our stackable version is all about. So you can have your own vertical farm in your own house, and again, it's good for those people who don't have a garden or have a balcony or something like that. So you can actually have, if you've got a corner of a house or a room You can just set it up and you can have your own vegetables grown or fruits grown in that.
So, Will, you've talked a lot about drones getting information. Do you have the land-based systems as well that will pick up information locally?
So land-based systems?
Systems on the ground too?
Yeah, so we try and connect to soil sensors and weather stations that are in fields. One farm can have 4 completely different soil types and 8 different weather systems. So having all of those is vital. It just everything comes down to cost. It's the same with what we've just been hearing about the Gantry System and Farmbot. If you make it affordable, then it becomes a no-brainer.
In your presentation earlier, what really struck me was that how much of the farmers' costs are in things like the fertilizer and weed killer.
It's shocking. So the farming has gone through a few big revolutions. The advent of the horse and plough, and then mechanized tractors and combine harvesters. And a lot of people think, oh well, drones and satellites, they're going to replace people on farms. There aren't any people on farms now in the US and Europe. They're literally, most of our farmers are 2,000-3,000 hectares or more, which is massive, and there's maybe 3 or 4 farmhands. So machinery in this instance will not replace the human labour element, because as an input cost, it's already sub 15%. But it will replace big wastage of chemicals and so forth.
If somebody in the audience wants to enter the discussion, they'll let me know. Raise a hand. Yes, question from Simon at the back.
The using Farmbot in an urban setting is very interesting, because it would mean that there might well be less need for large-scale agriculture. I mean, there'd be some crops that would be better suited for large-scale agriculture and some that people could grow themselves. I do not know much about this, but is there a realistic way of doing without the need for soils, through hydroponics or aeroponics, for the person growing in the city?
Yes, that's actually what we're going to be looking at. I didn't have time to put the slide up on this. Hydroponics and actually aquaponics we're looking at. One of our main investors is very keen on hydroponics and aquaponics. And as soon as we've built the stackable system, that's our next way to go on that side of things. Yeah.
Very interesting, thank you.
So the question, if we can pass the mic over to the other side. This is...
It's another Simon from Landscape Institute. I've been thinking laterally about both of your technologies. Will, I was wondering whether you'd thought about, or at all, use on golf courses because of water and chemical use there, or forestry. And Julian, I'd wondered about expensive ornamental plants, and actually now, based on the question behind, whether robotising the maintenance of roof gardens.
It's a great question, and I think just to tackle the forestry one first. So one of the things that we do is we identify disease at a leaf level, at a cellular level that is invisible just to our red, green, blue eyesight. I think, unfortunately, with forest, or good for forest, bad for me, there's a lot of biodiversity that you don't have, let's say, in an oilseed rape field. And actually, it becomes less of a kind of immediate problem, unless it's stuff like, all the big diseases that the Forestry Commission sort of worry about. So from that perspective, forests tend to look after themselves in ways that commercial arable crops can't. Having said that, the way we measure height and predict yield and so forth is useful for commercial kind of forestry enterprises. I think the wider point about drones and data analytics is that it's very easy to get carried away about thinking about applications for golf courses and so forth, just for a certain crop type that we try and stick to our focus. Having said that, we developed an algorithm for telling whether a cow is pregnant, for example. It took us a month, but it's not actually that helpful, even if it sounds really cool.
Going back to roof gardens and ornamental plants, certainly there's no reason why it can't be used on a roof garden. And again, you've got a very confined space there, but a structured space, so it could be scaled up to go over a larger area on a roof garden. But ornamental plants, then yes, certainly, and that's one of the things it is good for, is for high value plants, and also ones that are difficult to grow, because it's effectively a constant gardener. It's always there giving critical attention to the plants all of the time.
There's another question from the back there.
Yes, I'm just wondering if you could put one of these Farmbots in the corner or in the middle of each field, and that would produce expert advice back to the farmer to what to do commercially for the rest of the field. What do you think of that idea?
It might be slightly difficult there, because you'd only be looking over a very small area, 3 metres by 1.5 metres of soil underneath the Farmbot, and not over the rest of the field, because soil varies depending on the topology and the underlying soil surface and everything else on it. So I think it would work, but it only worked for a very small part of the field.
It might work in the fens, for instance.
It might work in the fens, yeah. We've got a very consistent soil surface, yeah.
So, Will, which changes in technology are the ones you're tracking most? Is it that changes in the performance of drones, that they're becoming lighter and faster, or is it changes in the AI software and the data analytics? Which of these are going to be the most significant for the evolution of your company?
I think we are that second part of the component, so I mean that's something we're actively doing all the time. For us, it's kind of it's a hardware combined with a regulatory thing. So, allowing autonomous, beyond visual line of sight, extended visual line of sight use of drones would be a complete game changer for this. If we could control them remotely, then we'll win.
Currently, drones are only allowed within the line of sight of the person controlling them?
Exactly. And someone mentioned the fens. So, up at James Dyson's place, we can fly up to 600 hectares a day. In Wiltshire, it's 150. So the more you can see, the better. I think, the hardware thing's an interesting one. So the drones that we use cost about £10,000, including the sensors and so forth. They used to cost about 50. Next season they'll be 5. Given that the cost saving for some of our customers is 50,000 and upwards, I think that the more commoditized they get, then the bigger the ROI and the more people will adopt them.
So what were these cost reductions again? 50,000 to 10,000 to 5,000?
Yeah, they're sort of halving every 6 months, I'd say. I mean, which is a natural. Think of the mobile phone. It's not dissimilar to that. So.
All right. And what about regulation of drones? Because it is obviously very dangerous if drones are flown by people and they make mistakes. They're showing them off to their family members and they lose sight of them and they crash potentially into aeroplanes or whatever.
I don't know. It's a hard one because all of our customers are sort of by nature in the middle of nowhere. Farming is about the safest place to fly one. So. We never see any people. I mean, we don't pose any public safety risk. I also think that because of the regulations, they have to weigh so little. So our whole system weighs about 5 kilograms. It's not much heavier than a football, so there's a limit to how much damage that a fixed-wing drone can cause with the polystyrene wings.
And are the regulators open-minded to the discussions you're having with them?
The UK ones started on a very promising note, but now are being painfully slow and just inefficient.
And what's the reason for that? I mean, surely they would like to see our agricultural industry saving lots of money and growing things more cheaply.
Well, you would have thought so, but I think that people are concerned about the Daily Mail and a drone flying into Heathrow and so forth. And secondly, there's one guy at the Civil Aviation Authority who's handling 3,000 applicants every few months, and it's not properly staffed, and I don't know, perhaps it's not politically high on the agenda, I'm not sure.
Right. And Julian, do you have any issues with regulators, or are you entirely in the government's good books?
Well, I don't think there's many issues with regulators at the moment with Farmbot, unless it suddenly gets taken up by lots of people who want to grow cannabis in the UK. But actually, back on drones again, that's one of the reasons why my company, we got involved with drones in the earlier stages, but we sort of put it on the shelf again, purely on the same problem. the fact that, that we couldn't get beyond line of sight. We wanted to use drones for security purposes that would detect intruders and launch a drone to go and track the intruders down and film them and everything else. But again, couldn't do that because there was no person there and it was not line of sight. And again, the CAA seemed to be a bit behind the times of things.
I don't know if either of you saw the slide that was shared earlier in the section on construction. It rated various industries. Wasn't exactly sure what they were rating them on, but it seemed that construction came second bottom in that list, and agriculture came right at the bottom. Did you see that? And do you have any comments on whether you agree with that, or whether that's just an opportunity for lots of innovation?
I think we're just about to jump over the top of construction industry at the moment with what's coming down the pipeline in the agricultural side of things. Because from what I've seen, and even listening to Farming Today on Radio 4, there's a lot of talk about automation in agriculture going on at the moment.
Yeah, I think I don't know what the source of the data was, but if you look at it globally, then maybe. But I think, US, European farming is highly advanced. Some of the equipment itself is, sort of spaceship level in terms of the latest combine harvesters and sprayers and so forth. So I think it's a game of two halves. It slightly depends on how big the farm is and where they're situated.
Did I see another hand up? No, maybe just somebody was stretching. All right. Any final comments? Anything that you wish you would want to emphasise as people can take away?
Not really, as far as I'm concerned. Although there's one question that people haven't asked in the audience was how much the Farmbot cost. The basic system at the moment is just below £2,000, which sounds quite a lot, but it is coming down. Hopefully, it's just down to getting sources of the parts. And
so you need to get this halving in price mechanism, which will come with greater economies of scale. But your problem is that you don't benefit from all the other uses. I mean, like drones are used in multiple ways, and so there's a whole.
That's right. Although, as I say, Farmbot is hackable, so there are other uses it can be put to. There's even talk about using it for use with chicken coops and actually keeping chickens fed and watered and everything else when people are away. So there's potential there, but like all technologies, it's very early stages at the moment. So it's first adopter technology, but in the next few years, it's bound to come down.
Maybe you'll give us a report when we're doing 6G world in a few years' time.
Absolutely.
Any final comments?
All right. No, thanks.
That's fine. So thanks to both of you and giving us a lot more to think about agriculture.